Hello, good morning, everyone. I hope you can hear me. Renaud, if you can confirm, that would be great. Okay, perfect. Thank you very much for joining this webinar today about grid solutions and also challenges for data centers in Wallonia and Saxony. This webinar is organized in collaboration with Saxony Energy from Germany. With a cluster Tweed, of course. My name is Rémi Balégamire. I work for cluster Tweed. I'm in charge of all topics related to grids and local energy management. If you go next, Renaud. So what is Cluster Tweed? We are an organization that gathers actors in the energy sector, but also we work in the water sector. But the topic of today is, of course, about is more related on energy. What we do actually is to bring together several actors from the private, public sector, but also from the academia to work on innovative projects. The planning of today is split in two main zones. So we'll make a zoom on Wallonia to talk about what are the challenges for data centers and industrial electricity automation and IT within the data center domain, and then we'll move on to the German part to talk about the energy storage solutions and also the activities that is executed by some companies. Quite an interesting one we'll learn today. Maybe without talking much, I will give the floor to my co-host, André Wiel from Energy Saxony. André, I see you are in the room. Maybe talk to us about data centers in Germany and maybe a small presentation of your organization in Saxony.
Yeah, I can do. Hello to everyone. My name is André Wall. I am the General Manager of Energy Saxony. And can you go to the next slide, please? Yeah, and even the next one. Yeah. So Energy Saxony is a energy cluster in Saxony. So what we do is networking of economy, research, and politics in the Saxony area with actually 84 members, mainly SMEs, but also larger companies and research institutes. And I did a short overview of what in Saxony is going on data centers. So you can go to the next slide, please. So the current situation is that Dresden is the main data center hub in Saxony, but it's a strong focus on research institutes and high performance computing and public IT. But there is not very much presence of hyperscale applications also. But what we see is also the area around Leipzig has a growing commercial data center ecosystem. But there are a lot of planned projects, especially in the region of Leipzig. So there is a new AI and research data center in the Alte Messe, and there's also plans in the conjunction with structural transformation in the Coil area there with a public data center. And there is a plan of a hyperscale campus in the area of Leipzig and Saxony Cloud, what is also a funded project. So there are some plans in the area of Leipzig in the next years, but maybe others come up. So what are key local drivers for Saxony? There is a pretty good power grid capacity. There is land available, especially in the in the area of Leipzig, we have a growing demand on AI and cloud computing, and even the infrastructure is there due to the former big consumers of energy and also provider of energy in Saxony. And this gives a cost advantage in some compared to other regions. A strategic outlook maybe. Right now, Saxony is more a research-driven and commercial data center market, but very small. Dresden will remain on research probably, but Leipzig has a chance to grow. But it's still some years out, but it's good to hear what's going on in Wallonia and to learn from there and see what is applicable for Saxony and what we can learn there. So I'm very interested what we will hear today. So handing back over to you, Remy.
Thank you very much. And actually, data centers have been in the spotlights for a while now regarding their impact on the grid, on water, but also the increasing stake of data centers in the industry and in the economy in Belgium, but also in Germany and other several countries across Europe. So you can see here, some of you might be familiar with all these titles in the press that is. Have come up in the last weeks, last months. But let me try my luck at giving a short definition of a data center. I take the risk, but the real experts who are in the room, in the audience, could maybe tell me how I was wrong. So are data center important? Well, yeah, it's what maybe knowing first what is a data center. And a data center is a physical facility that stores, processes, and distributes digital data and applications through servers and networking equipment. So are they important? Yes, data centers, they serve. Every email we send, every video call we join, every file in the cloud, including this webinar, is made possible thanks to data centers processing and moving data, our voices, videos, and messages in real time. So they are important. Is it for each use? Maybe not. It's important to mention some key elements as it's portrayed here on this slide. You see that globally, nearly 1.5% of the electricity was consumed by the data centers, 415 terawatt hours, and this is said to be doubled in 2013. So we see a massive growth in electricity consumption, also due to data centers. And why this? Because of course the rise of AI, cloud streaming. We all use Netflix or this kind of subscription to see movies and series. But also we are experiencing an increase of development of hyperscale data centers, and it's not only in the US. We tend to think that, the GAFAM companies are mostly based there. We see that there's a power network availability that is being or becoming limited, and companies actually are moving from the US and other locations to try to see the opportunities here. Here, for instance, here in Belgium, we are reaching 4%, which is close to what is in the US in terms of electricity demand use. So here in Wallonia, what I've put it here on this slide in Sigulla, this is a data center of Google. If you go next, Renaud, we can see I've just added a few minutes ago this graph, this figure, which I think is very appealing. You see it's from the World Energy Outlook special report from the IEA, and you see how it's going to be developed. Actually, the installed capacity is going to double according to what is planned as of now. Now, next up, please, Renaud. So, besides, we have a system which is already under pressure. Most of you know it's already due to the increase of electrification to respond to the electrification of industry, mobility, heat pumps. Data center also comes as a new player. And as I have mentioned before, in Belgium, we are now reaching around 4% of the electricity demand, and it's set to reach 10% in 2035. There is already a grid, some grid problems. In Wallonia, we are now experiencing long queues to get access to the grid, and also these data centers projects might be also seen as sometimes an issue, sometimes as a solution, but that is what we're going to explore today. Next, please, Renaud. Now, there's a reality in Wallonia. There's a reality because the grid is at risk of being saturated. There are long queues, and yesterday we used to hear about the challenges of getting everyone access on the grid. We talked about industrial decarbonization, mobility, buildings, and so on and so forth. And now, next, please, Renaud. We have a new player, as I have just mentioned, but should data centers be considered as a competitor compared to the classic uses? To address this, there are some initiatives emerging from the governments, grid operators, and other key players to mitigate the risks of saturation, connection queue, optimal allocation, etc. And in new developments, instead of treating all uses the same way, they are taken apart as a standalone category in terms of allocation to of access to the capacity. And one of the solutions, which is not only for data centers but for many uses, is the flexibility. I will finish by showing us a small graph here. If you go next, Renaud. Well, the electricity can. Well, the flexibility can be used actually to allow for other uses to get access to the grid. And then you see this is from the map of the transmission network operator here in Belgium, Ilia. You see that for capacities starting from 100 megawatt, with zero flexibility, you only have one spot in Belgium. If you move to 5% of flexibility, you have more, and you can see it's 20%. There is even more, so there's more space for other uses if we put we use flexibility. And this has been also mentioned in the Amber report. If you go next, Renaud, where they actually pinpointed the data centers as part of the solution. Next, please, Renaud, because actually they are considered as there's a very good capacity with the flexibility, possibly moving from 0 to 50 or even 75%, which is already quite big for the flexibility for the grid. So we follow very much this flexibility topics. And before I move on to our speakers, if you are interested, I invite you to join us on our next event on flexibility, the first one coming on next 25 June and the other one 8 September. I won't go further, but if you have any question, I see some hands popping up. Please share your questions in the chat, so we can move on in the chat box, and then in the end we'll come back to them so that the experts which are invited here can respond to them. Thank you very much. So now I will maybe pass the floor to the first speaker of the Wallonia Zoom, and that is Nicolas Coppee. If you can share your screen, please welcome. Thank you.
Okay. Could you confirm you see my screen?
Yes, yes, yes.
Perfect. So thank you, Remy, to give me the possibility to explain a little bit about the situation in Belgium, and at least in Wallonia. It's also a good transition because I also would like to discuss about flexibility. So a good transition for your future events. I'm quite interested by. Could be interesting. For you, I create a small quiet agenda with what's the data center in Belgium, the market, and how we see it, the evolution with LCL. Maybe if you don't know already LCL, and the great challenge for LCL in Belgium. For us, the visibility on the future, it was a map before the AI story. AI has changed the paradigm in November 22. If you know ChatGPT, when it's pop up, it changed completely the paradigm in the data center world. So the Belgium is not a big key player onto the data center. I can say we are just at this level, so not a lot of data center in Belgium, but the Belgium become more important because you are the center of the Europe, and the France is different, but UK is full, Netherlands is full, Germany is also interesting. So that's why the Belgium we see a very important market. Before in 21, we made this study. We received this study from McKinsey, and they put this kind of growth between 15 and 20% by 2030. Since the 22 story of AI, the ChatGPT, now we are more focusing to, the idea was mostly 40 gigawatts just in Europe. I'm not mentioning like you for the complete worldwide, but you expect 40 megawatts without AI, and with AI it's become 55 until 60 gigawatts. And with geopolitical, it's also a new story for the data center, because now we are discussing about sovereignty. It's very important for our customers. And so the geopolitical with Mr. Trump, you know, the evolution is also moving quite fast, and we see 75 until 80 gigawatts by 2030, 2032, 34, depending of the future. With LCL, LCL is a Belgium key player. I would say one of the top two. In the top two, I have a slide to visit the top one, but we have the only one company in Belgium with Belgium fund behind it, just completely independent, without any American company behind us. It was very powerful for us, with a growth of 10% year after year, and that was the figure since 2002, and now the growth is very exploding because of AI, and also we are discussing with a lot of hyperscalers. And hyperscalers change also their mind. In the past, they put big data center like all the hyperscalers, and now we see they're also looking for the AI and increase the density of consumption by the square meter, let's say. What is important for LCL, it's also the classification. Certification is very important for us. So that's why the customer coming in at LCL, because they don't want to receive all kinds of certificate by their own. So when they put their own IT into LCL premises, they have the access to all the story, like 14, 27, 2001, 50. You can read if you want afterward. It's not the main interesting for today. And compliance, maybe the NIS2 and the DORA is quite important for the Europe. And if you are looking for the cloud, if you're discussing with IT companies, cloud is interesting, because if you are going to put your IT into American's cloud, okay, be aware you could share your data with Americans governments, but it's up to you to decide. Okay, so that's the big question for today. What's the big deal for us in terms of data center electricity capacity in Belgium? The first one we see is the flexibility, because now the grid asks data center to receive the same flexibility, and they treat us like any other industry, but obviously it's difficult for data center. I will explain later on. And the access to the network capacity, network connection is also a little bit linked with that. I will dive afterward. For the flexibility, like I said, like any other industry, maybe just to put the figures, what is at the end of data center. Data center, like you can see on the left side, we just consume electricity. What we do with electricity is very easy. So today we consume electricity from the grid, most of the time renewable production, but when you don't have wind, you don't have sun, obviously we still have the nuclear plant, gas station, but at the end it's not green, sorry. But for the renewable, we try to use most of the time renewable energy, but it's not completely feasible. If you have a data center of multiple 10 of megawatts, it's become difficult to have storage to have 100% from solar and wind. The backup generator, they are just here in case of. It's not what we want to use on a daily basis because it consumes fuel. Maybe most of the time we are now moving from gasol to now is HVO 100. It's less emission of CO2, but it's still some things we use in the worst case scenario. The good things in Belgium, we have a stable grid. That's very important for us. But yeah, in case of, we still have the generator. The generator are designed for 48 hours without any refueling. But yeah, 48 hours, it's not so much big deal. Electricity fill up or UPS system. UPS system is just between the switch between the grid electricity until the genset is up and running, and we can continue to feed the data center IT load. Otherwise, we have big deal. And beside the UPS and all the power distribution, we have also the cooling units. To give you an example, for 75% is the electricity consumed by the data center is used by the server itself. By server, I mean storage, networks, device, and all this kind of stuff. 15% is used by the cooling units. Hopefully in Belgium, not for everyone happy with that, but for us, the temperature is not so much. So it's good for data center because the temperature into data center is between, the norm is between 17 up to 27 degrees. Most of the time we are looking to 21, 25 degrees in front of the servers. Means 15% of the consumption is dedicated for the cooling units, 8% for the electricity distribution, because the efficiency of the UPS, the preheat of the generator, this kind of stuff are part of this consumption, and the last 2% for the old utilities. One big topics we want to look for the future is reuse the heat, because 1 kilowatt consumed by the data center on this stage is transformed to energy, heat. And the goal of LCL is to reuse the heat to create a good ecosystem. And instead of to have a pool, you have to heat the pool. It's better to use the heat from the data center and to put into the pool, or to reuse via heat network and this kind of stuff. But this story is very, very difficult. And if you want to manage all the story like electricity, access to the electricity grids, the land, very important. The data center you prefer to put in middle of nowhere, and the pool is closed for the citizens. So yeah, sometimes it's difficult. Why data center cannot offer flexibility? It's very logical. If you look into the market, the industry, manufacturing, if you have a heat for a process, maybe you can stop the process when the price is too high, or the flexibility requires a shutdown of the industry. Maybe it's not possible, depending on the process. Office buildings, maybe you can shut down the cooling, maybe you can shut down lights, depending also on the big consumption. Car is very important. Maybe I guess we can stop the loading of a car when the flexibility needed. For data center, it's difficult. If you agree to don't pay some things because you have not sun outside and no wind, and you stop the bank transfer, you stop communicate with your family or your colleagues, it's very not possible. Cloud services, it's also not possible. Netflix, maybe, I guess it's possible to shut down the Netflix services during the flexibility request, but I'm not sure it will be welcomed by the the citizens and all the customers. So that means a shutdown of a data center is not possible. And beside this, a shutdown, it's always possible, but the restart of a data center takes hours and sometimes takes days because the system is not is designed to be up and running 24/7 without any interruption. That's the main topics. And if you have a hard shutdown, there's also a big risk of data integrity risk, and all of those stories you can read on the screen. But most company can reduce the electricity consumption, but IT must stay on, like I explained. And also in industry, if you have big buildings, maybe you can shut down the cooling, but the IT into the manufacturing must stay up and running. And that's also a purpose for LCL. LCL is a colocation data center. And by colocation data center, our customers are multiple. We could have some banks, some hyperscaler, by the way, and also some manufacturing, some hospital, and this kind of stuff. And flexibility for those kind of customers is not possible if they're in-house data center. And the purpose of data center or colocation data center in the past, before the flexibility, was most of the time the accountability. In the worst case scenario, if the data center is not well managed, what's the impact? They prefer to move the IT from the on-premises to a colocation data center to transfer the responsibility to have a contract with SLA, KPI, and stuff like this. So it's also a reduction of CapEx because a small data center with 50 kilowatts is not a big deal in terms of CapEx if it's embedded into a large data center. But if you have to start from scratch into your own premises, it becomes very, very expensive. And maybe the company don't have the CapEx, and that's not the purpose of this company to use their own CapEx for a data center. It's better to use the CapEx for the process, let's say. Physical security, logical security, and we don't manage the IT, but we manage all the physical stuff and compliance, like I explained. But in the worst case scenario, if a manufacturer receive the light to shut down the process because they have a request for flexibility, like I said, it's not possible to shut down all the IT stuff. That's why we are forcing, motivate all the colleagues, the customers and the authorities to move the IT from premises to colocation data center and offer connection without flexibility on data center. And in this case, we could create a happy story. And the happy story will be when you use the heat of the data center to feed another activities, let's say. Network capacity. It's also a big deal for us because, like you know, and like explained by Remy, hyperscaler detect the Belgium like a very good location to put big hyperscaler and big consumption company. And today for the Belgium is very, very critical. We see very critical because colocation data center in Belgium, we're supporting the business. Without IT, it's not possible to create, grow, and to create industry in Belgium today, in this world. Some companies going to the hyperscaler cloud, like Amazon, Microsoft, Google, okay, very good. But for critical activities, it's not possible to go into this kind of services because you don't have, in terms of flexibility, business continuity, it's very, it's a risk to assess. And if you agree on, it's your choice. But I can't imagine for a company to put the SCADA network into a cloud application. It's not feasible. And today, what we see, the hyperscaler ask multiple hundreds of megawatts, and they destroy completely the Belgium network because the access for company like LCL in Wallonia, for instance, we're looking to receive a grid connection, and sometimes receive the request, okay, but in this area we have already Google consume too much energy, so it's not possible to deliver for you electricity. So I guess it's not what we want in Belgium. We want to create in Belgium an ecosystem, and this kind of hyperscaler, if you look into Google, you can locate the data center they have. It's most of the time in Ireland because of the taxes, UK, Belgium, Netherlands, Germany, and all in the north, actually. But there are no things in the south of the Belgium. So that means all those data centers are deliver services for obviously the Belgium, but also for other countries like Italy, maybe Spain, etc. So you have to be aware this kind of hyperscaler, they consume electricity locally, but they don't deliver only services locally. Okay, they create some FTE locally, but it's not the main concern for them. That's why it's a very, very big deal for us to receive some electricity. I make a small Gemini request to have a kind of idea what's the new, the actual situation in Belgium. Like you can see here, LCL Data Center is quite accurate. Today in Belgium, we have two big players, Digital Reality, American's company, by the way, and LCL now is very growing, and LCL become, I'm not completely sure because I guess Charity is a little bit higher, but anyway, LCL is the only market leader on Belgium market. And beside this, we have hyperscaler, and the scale is a little bit like this. They are 10 times more consuming regarding LCL in Belgium, and Microsoft is a little bit different because they also rent data center. And you have also small key player, very important to the ecosystem because we don't want to be the only one in Belgium. It's also interesting to have competition because the competition is also a way, if something's happened with one actor, you can have the redundant IT into another player, let's say. Yeah, so you can have an idea of the figures, and today is very difficult for those players. The connection is completely different because they go to the not to the alien connection. Most of the time they can go to the JGRD and not to the TSO. So it's quite different for them. So if you have any question, feel free. I'm happy to share a little bit more when I can't on topics I can explain, but times it's not.
Thank you very much, Nicolas. It was very interesting and pretty clear. I propose we keep the questions if there are. I see maybe there are some in the chat, but maybe we keep them for the end. But thank you very much. Myself, I might have some question for you, but let's move on to Technord. Maybe David, Robert, you can share your screen, please.
Yep. Okay, do you see it?
Yes, but not the
Yes.
full screen.
Yep.
Perfect. Thank you.
Okay, all right. So thank you for the opportunity to present some thoughts we have about this this kind of subject. As you can see, I've taken a question that arises from the cluster Tweed. How can automation and industrial technologies concretely make AI data center more flexible and energy efficient? And just sharing some thoughts about this, in fact. But first, I will present Technord. Technord, it was called an industrial integrator, and to present the skills and competencies we have, I've chosen to pick up the pyramid CIM, representing the layers into an industrial process. And it's also representative of the evolution of the skills of Technord, because at the beginning, it's in 45, the founding of an electricity company. So you have the bottom layer. You do you hear me?
Yes, we do.
Okay. And so you have this layer of electricity by the company TEI, Technique Électrique Industrielle, founded in 45. And then when the technologies just have evolved, the company just embraces these new technologies like process control and PLCs at the end of the 70s, SCADA supervision, and then the MES, so the IT layer, industrial IT layer that will pick up information from the ERP and translate fabrication orders into real-time operations in the beneath layers. And so this, I would say, the skills and competencies are classical for Technord. And when talking about the industry 4.0, 5.0, we were wondering what new competencies we could acquire. And so intuitively for industrial integration, we turn to industrial Internet of Things, so mainly using new latest technologies for sensors and networks for to bring data to the user. So mainly on batteries, sensors, bringing the new information into the control room, database, the cloud, and so on. So we can get rid of the cable situation. And on the right side, you have the AI part. And as all the other colleagues are generating a lot of data among our customers, the idea was to exploit this data and provide new services to the customers by optimizing their processes and bringing some decision support. And we do data-driven modeling, classical AI, statistics, regressions, and machine learning. But as we are also into industrial processes, we do dynamical modeling with based on physical balances like mass balance or energy balance. And I will explain later the notions for software sensors and digital twin. Just regarding numbers, we are a family-owned company. And Technord is existing for more than 35 years now, so the name Technord Holding, but as I said before, it comes from an electricity company founded in 45. We are around 400 people for the turnover, the staff salary, and you can see the turnover here. We have a lot of projects outside Europe because we have a lot of customers that are international. We are based in Tournai, Liège, and Wavre, and also Charleroi, and in France, we are based in Lille, Orléans, Lyon, and Dunkerque, and we have some addresses to follow some customers in the Netherlands, in Scandinavia, Romania, and South America. And as the company exists for many years now, we are into different sectors, and of course, we are into the data centers sector. We are also well placed, I would say, the best workplace. We are a B Corp company. We've been Company of the Year in 23, and it is a part of the company that's open to the investment for the employee. And so the expertise for the data center solutions in the case of Technord, you can see here, I would say some points about this, and it's in fact it's between hardware, material solutions, about cabling, about integration of electrical equipment, high voltage installations, as you can see, but there is also the software side with 3D BIM, so that we can model the buildings and procure an accurate plan for the data center, for example. And we have also the implementation of PMS and BMS, so power management system and building management system, which are really important for the data centers because it will just rule up, I would say, the management of power and also see if everything is fine and try to optimize some processes. And so today, as I'm also, I would say, business developer for the optimization activity in Technord, we'll talk about some thoughts and discussions we have with colleagues and our customers about these aspects. So if we start with from the question of the title, just to remind that in fact the objective for data centers is selling the uninterrupted availability of information. And as Nicolas Coppee mentioned also before, it's a question of energy and it's a question of cooling systems because you need energy to make the things running, but you have also to cool down all the machines that are involved into the data centers. And so at this point, we have just discussed about also about this KPI, which is the power usage effectiveness, classical KPI about the management of energy, and you can see that it's 1 plus what's not used for IT facility and divided by IT equipment energy. And so it means that they want to really optimize energy just for the IT equipment energy and decrease the non-IT stuff. And as mentioned by Nicolas, in fact, we have observed, of course, that there are some things to do about the reuse of, I would say, the hot water coming out from cooling, because we've observed that, for example, some heating system into data centers are completely independent from the heat exchange and the cooling system, meaning that they use energy to heat buildings and offices and so on, and they don't use this opportunity to use fatal energy from the cooling system. Of course, like any most of industries, there could be consumption peaks some time to time. It could be good to predict and to foresee what could be the consumption peaks and have then the right actions behind this from a production perspective. If we now are talking about the maintenance perspective, there are a lot of things to do because there are huge maintenance tasks to do on a data center. When you consider maybe large installations, it would be good to coordinate the maintenance task with efficiency and avoid to open up, I would say, an asset 2 or 3 times on a month because you have some maintenance that's planned on this asset, and maybe have some more efficiency with a smart scheduler about this kind of stuff. There is also the question of the alarm management because, as I mentioned, we implement PMS and BMS systems. So these systems raised a lot of alarms, and it could be also a difficulty somewhere because as it generates a lot of alarms with not always clear, I would say, prioritization, you could be drawn into a noise of, I would say, non-impacting alarms compared to the huge and I would say emergent, I would say huge alarms that need emergency for intervention. And from the perspective of the cooling system, what we see, of course, as discussions for optimization is to integrate more and more the cooling system within the servers and IT infrastructure. Just an example on the right side of the slide, I've seen this publication about what could be used as new equipment to increase the efficiency of the coolings. And there are also the management of water, I would say, in the wall, like the impact of the disinfection of water that's used into the cooling system. And when you have to, I would say, drain out the water from the system, you have to check also and monitor, of course, the pollution that could be generated by this kind of product, simply chlor components and so on. And also considering, of course, a general overview of the water mass balance used into this kind of installations, because it's a key component, and so it's really important to contextualize, I would say, areas for improvement in that case. So when we're talking about improvements and so on, we're talking also about exploitation of data, finally, not only the material side, like I mentioned, but also the way to optimize. And so from our perspective or point of view, the idea is to optimize and use the data that are generated even into our data centers. You have to manage your own data. And so, as mentioned before, we can propose then solution to our customers by doing hybrid modeling, so a blend of data-driven modeling and science-based modeling. We will use historical data, real-time data, and process understanding to have KPIs and anomaly detection or predictive maintenance, which is also an important point. You can see the software sensors and digital twin that I will explain here. So the software sensor is finally modeling to estimate in real time quality KPIs in most of industries, but it could be done also in data centers. What do I mean by this? If you consider the current approach into a industrial process, you have online measurements, typically temperature, pressure, flows at high sampling rates, and you will define some performance KPI. But if you want to check quality, you have also to do some lab measurements, I would say, that are really at low sampling rates. In the case of data centers, would be the check of the pollutants at the outlet of data centers regarding the water. But if you check this, you know that you are right or not into your process. The idea of software sensing is just to exploit, I would say, the high sampling rate measurements like temperature, pressure, flows, and so on, so that you can I would say, exploit really the life of the data center. It's really meaningful to represent the life of this activity of the process. And so we'll use modeling to predict KPI of performances and also for KPI in terms of quality. And so imagine, I'll always take this example. If you take cement manufacturing, they have one measurement, one KPI, quality KPI that's measured every 8 hours. It means that the operator will do his work during the shift, and then he will get the results from what he has done. It will be good or less good, but what's done. And the colleague that will come up for the next shift is again blind about the quality of what he will do. And so the idea of software sensoring is so to say, we will estimate in real time this quality KPI so that we have an idea of the kind of quality you are producing. So it could be useful in some aspects. And regarding the real-time optimization, we'll take, of course, the digital twin notion that on a industrial process, you can also call advanced process control. It's the classical stuff. It's not a new invention from the 4.0 context. And so in that, with this tool, you will check the process that will generate a lot of data. This data will be used by hybrid modeling that will predict what will happen in the next seconds, minutes, hours, depending on the process you're studying. And you will compare that with the KPIs, the targets that you want. And the delta between this prediction and the KPI will feed the optimizer. And this optimizer will just take into account also some mechanical constraints, pollution constraints, and so on, and then calculate a set point, a new set point on the process that will optimize the process and keep it on the trajectory for an ideal target. And of course, in terms of maintenance, you can work on conditional maintenance, meaning that you will define thresholds for warnings and potential failure for your equipments. And when you implement this kind of material, most of the time you will just say, okay, the warning threshold will be this one, failure will be this one. And you don't take into account, I would say, the fact that the equipment will just will grow old. And so maybe the thresholds are not that relevant anymore. And if you make some repairment or revamping onto the equipment, maybe you have to redefine these thresholds again. And then dynamically estimate these thresholds based on the latest data that you have produced with the equipment can be really relevant. Or you can go further and do real predictive maintenance, meaning that at the present instant, you will use data on the equipment and other satellite data that could be useful just to predict how the equipment will behave in the next hours, days, and so on, so that you can have, I would say, replanify your maintenance task. And so when you do this kind of project of optimization, you have most of the time 3 big steps that are just mentioned here. You will have a feasibility study, which is the checkup of the data that you have in terms of volume, but mainly in terms of quality. So you have to check if you have good quality data, so have, I would say, fundings for a good modeling and then a good optimization. And then once you have checked this, and then you have defined some return on investment, you can go to step 2, where you will exploit historical data, do a kind of simulation, and then see if you can fit curves on the measurements and represent the system and have some simulation for predictions. And then the third step, of course, if needed, you can go through towards real-time optimization and saying that, okay, the measurements are coming up. In which situation am I? Which model or which set of parameters have I to use to get the good predictions and then regulate and control the systems appropriately. Just a question at this moment. Am I right about the timing for the moment, Remy?
I think you're getting there.
Is that okay?
If you don't mind.
Or?
Yeah. I think 1 or 2 minutes.
1 or 2 minutes? All right. Just to show an example, but not in data centers, because we are, of course, I would say, linked to some NDA and so on, but it's a similar example. Just to say that we have already, of course, developed this kind of tool into other sectors, like drinkable water, in that case, where we have developed a tool to optimize the pumping schedule into this plant, because they were following from in the next months, I would say, the evolution of the kilowatt-hour price. And so they wanted to change the common way to drive the process. And so we have taken into account their possibilities about buffering, the new ways to pay, to have the electrification payment. We have integrated the pumping curves. We have integrated the practice about the way to use these pumps, because it's huge pumps in that case, and so you cannot switch them on and off every 30 seconds. So you have to switch on at least for, I would say, 15 minutes. And as it is manual manipulation at the end for the switch off and on of the pumps, we had to limit also the number of moves onto the pumping during the day for the operator, so that they don't get mad. And so this kind of tool, for example, has been developed and is running for 2 years now, with a return on investment that has really has been well identified. And so this kind of initiative could be also applied to some data center customers, of course, about the reuse of energy, about optimization of the cooling system, and the use and the management of, I would say, the energy consumptions. I will just stop here to remain into the nice timing that we have for the moment, if it's okay for you. Is that okay, Remy?
Yes, perfect. Thank you very much, Robert. And now we move to the Saxony region. We start by skeleton. Dr. Markus Klose, if you can share your screen, please.
Yes, and just give me one moment. So you should see my screen now. Is it correct?
Yes.
Yes. Okay, excellent. All right. Yeah, then thanks very much, Remy and Andre, for giving me the opportunity to speak here. My name is Markus. I'm responsible for IP and some ground topics at Skeleton Technologies. We are a Estonian-German provider of high-power energy storage solutions, and don't worry, I will not bother you too much with company presentation and commercial topics here, but I guess I'll just dive right in. So what you can see here on the screen on the right side is Europe's largest supercapacitor factory, which is operated by Skeleton Technologies. I'm going to explain a little bit what a supercapacitor is and why high power energy storage is the core of our business and what it is used for. But maybe taking a brief step back, so the statement that basically in the end you'll see why I make this here is that AI infrastructure requires high power energy storage. This means basically the data centers themselves, but also the grids. Yeah. So if we look at this here, AI infrastructure, for example, looking at an AI data center, there are different levels. You start here on the top with the grid connection level, where you have to do maybe some power buffering. You have the distribution level still ahead of the data center, then the individual row level, and also the in-rack level. These are several layers basically which you will have to address depending on the type of data center and the resulting or connected application. One of these fields may be more relevant to you than the other, but overall, all of these require high power energy storage in order to do some sort of buffering. Yeah. So maybe a few words about ourselves. So Skeleton is, as I mentioned, an Estonian-German company. We have several sites. So our headquarters is up here in Tallinn in Estonia. We have production facility in Germany, which I've just shown on the screen. We also operate a battery facility in Finland and some engineering unit in France. Overall, we're about 360 people, so not an SME anymore. And we have investors from Siemens, Marubeni, some of them which have been partners before. And you can see here also from the list of customers, we're in a, let's say, still in a niche field, but a pretty broad niche. So we're serving, let's say, several different applications, so from specialized industry machinery to data centers, of course, but also to mobility and space. So what we do basically is we cover the value chain for high power energy storage from the very start, so from the raw material to the end, to the system level. Yeah, so we produce our own raw material, which we call curved graphene. We use this in individual single cells, but typically single cell is not something that most customers are interested in. Most customers actually do require modules or systems. System is typically a combination of several modules. Yeah. The module in the end itself is also several energy storage cells connected together with a battery management system. And then again, as I just said, these modules can be put in systems, and these systems or these modules can go into grid stabilization and also AI data centers. All right, so briefly highlighting what our products do. So to be very clear, supercapacitors do not compete with classic lithium-ion batteries. You can see this here on the left, the comparison of a lithium-ion battery, classical one, with a supercapacitor. Yeah? So both of these systems have very different working mechanism. In a lithium-ion battery, you really use the bulk of the active material. In a supercapacitor, you only use the surface of the material. This results in much less energy of the supercapacitor. Yeah? The supercapacitor itself has a lot less energy than a lithium-ion battery, which is mostly targeted for high energy cases. However, what a supercapacitor can do very well is provide high power. And you can see here more than an order of magnitude higher than what a lithium-ion battery can do. Also, supercapacitors live typically much longer. The lifetime is much extended, above 1 million cycles under actual use conditions is the standard. And they're also very safe. There's no thermal runaway or self-ignition of these systems. So I'm saying that to highlight that our products do not compete with lithium-ion batteries. Instead, they do fill a gap that is existing in the technology. And maybe to show this a little bit more, so classical supercapacitor is used between in a time frame from a second to 60 seconds. And you have another line of products which I'm not going to explain too much in detail now because of the time. We have also a hybrid between a supercapacitor and battery, which we call a super battery. Here also the application frame is maybe up to almost an hour, 45 minutes, half an hour, something like that. But overall, you see that our products fill a gap of very short time frames in which high power is needed and not so much energy. So where are these systems used? Well, as I mentioned, in AI data centers, so for power smoothing, of course, both in rack or on the grid level. You can also put these into so-called battery backup units, meaning basically similar to UPS systems, but they will not really replace UPS systems. So battery backup units typically last for, I would say, up to 5 minutes, maybe maximum. After that, then there are other solutions, some of which we've just heard, that take over. So this is really just a short time coverage in the case of a power outage. Then, independently, of course, of AI data centers, you can also stabilize the grid, virtual inertia grid and e-statcoms. It's a very big topic in Europe, especially since the increase of decentralized energy and power generation and the loss of inertia in the system. So you have less turbines connected to the grid that can compensate for that. So you have to compensate power fluctuations and spikes in a different way. And then, of course, we can put these systems also into mobility. So for engine starting, hybrid drivetrains also on trucks or trams or trains. Industrial power is a big topic. And of course, there are also some defense solutions, all of which are focused on high power. All right, but getting back to the grid and data center topic, we are looking at latest numbers for this year are that only US hyperscalers want to invest more than 600 billion into their data centers. Yeah? And for 2027, actually, the number is higher, even higher. Projected is 800 billion. So it's a massive topic, and that again is just the US alone. If you just focus on what's happening in conjunction with that. So the grids or the power grids are already operating at the edge of their capacity. Yeah. So There's a lot of, let's say, players that do need power from the grid. And remember, often the infrastructure was designed years or decades ago, actually more decades ago, and is not intrinsically ready for these big data centers and other customers to be contacted or connected with it. In addition, the more decentralized generation of energy, so windmills, solar farms, and so on, are leading to a structural loss of inertia, meaning basically you have less capability to stabilize the grid frequency. And all of this basically together leads to a rather unstable power grid that is more prone towards blackouts, which of course is not something that should actually happen. Yeah. For the US, for hyperscalers in particular, what do they do? Well, they do reduce their computing power in order to not have these high power draws, so that's what they call GPU burn. They have to compensate for the lack of energy. You may know that basically a lot of energy is wasted in AI data centers. I will expand a little bit on this later. And of course, the lack of grid connection is that very often data centers are being built and it's not sure if they can actually be connected to the grid. Yeah. So from the perspective of a hyperscaler, these are three very, very big problems that need to be tackled somehow. So to make it short, you do need instant power buffering in order to solve at least some of these problems. Yeah, and what we basically do is we provide systems that you can see here, typically on rack level, that can go into either these eStatComs, you can put them onto the power distribution units, or on the row level, also inside of the data center into the racks themselves. But let's maybe start with the grid level. I think this is the most obvious and most classic example here. So how does this look? Well, you can see, for example, some modules. We call them SCALMOD, supercapacitor modules. These go from voltages per module from 102 to up to 162 volt. Standard size made for 19-inch racks. Before you ask, of course, yes, you can put these things onto ships, but also on planes, because supercapacitors can be discharged to 0 volt. It's actually a very nice side effect of this technology that, in contrast to batteries, these systems do not have any residual energy left. When you fully discharge them, they're really physically empty. There's no more charge left, so you can basically send them anywhere in the world rather quickly, and you don't have to obey all these safety regulations that you typically have with lithium-ion batteries. Then we put them basically for grid use or in eStatComs into either these, let's say, what we call low voltage systems up to 1500 volt. And that means basically 10 of these modules in these racks, together with one master controller and maybe some auxiliary power supply. You can also, depending on your use profile, add additional cooling. So intrinsically, these modules are made for air cooling, but you can also add liquid cooling plates is also possible. And then if you want to go a little higher, you can of course also use the high voltage systems. These come with, it's shown here a little bit, with additional insulation, especially for high voltage, of course, is very relevant. You can go above 100 kilovolt for specific applications. Yeah, so this is possible basically directly for the grid for eStatComs, so outside of the data center. Now, if we look into the data center, the story is a little bit different. Yeah, so in the data center, you have within the data center itself a lot of power swings. How does this look? So for example, you can see here, just focus on the bottom graph, for one rack or one GPU, you have the power draw that goes on for about a second and then it quickly drops. And then there's about a second without a power draw, and then it goes back up again, and this is basically always a 1 second on, 1 second off profile. This is because when the GPU is calculating, you have these phases where actually the calculation happens and then the data is being sent, and then there's no power draw, which is this blue line at the bottom here. And so of course, if you multiply this by the scale of a data center, this leads to power swings for just one data center in the frame of megawatts. So this is really highly problematic, and this is why we've come up with a solution that you can see here. It's also an energy storage module with supercapacitors, which we call graphene GPU. Does not comprise a GPU, it comprises only the energy storage that basically smooths out these power peaks here. Yeah, so the orange line you can see is basically the same load profile on the GPU run in conjunction with our module, and you can see that the power draw, so the orange line, is much more stable than it used to be before, because the supercapacitors do take up the energy when it's being released, and they give it back to the system when it's needed, and this can be done constantly 24/7 with these 1 second on or 1 second off cycles. Question that very often then comes as well, why is this actually needed? So where does this power swing come from? And this is actually something that's explained very nicely in this article here from, it's a blog post from NVIDIA, that in AI data centers, in contrast to regular data centers, where basically the power usage equals each other out, you have some cores that are sometimes activated, sometimes not. In AI data centers, you have to synchronize the whole data center. Yeah? And this means basically you have several rows of cores or GPUs turned on and then turned off at the very same moment. And this leads to these giant power swings, which need to be compensated. And the module that we're showing here is one way of doing this inside of the data center. Yeah, you have to sacrifice some space in your rack for this. You could also do this again, as I've shown with the grid solutions, outside of the data centers. It depends a little bit on what the customer prefers. Yeah, and then if you basically extrapolate that to the whole data centers, here you can see this is how it looks for one data center, power draw of about 180 megawatt. And then in between these use cycles here, so basically here is a use cycle, and then here you have to burn off the energy, because what the grid can absolutely not handle is the power swing. It can handle a high load that is constant, that is possible, but a power swing is very hard or much harder to compensate for. And this you can basically now then buffer with the supercapacitors, which also as a nice effect in the end has a much lower overall consumption because you burn off less energy. Yeah? So you end up with these about 100 megawatt, a little bit less maybe for this one data center that used to require about 180 megawatt. All right. Now closing the loop here, basically this means these products can be used both on the grid level to stabilize, but also in rack, depending on what you want to do. And in light of the time, I think now I also have to come to the end. So I'm just going to show here the take-home messages from my little presentation. Thank you very much for your attention.
Thank you very much, Markus. Actually, it was very, very appealing. Actually, and it's worth mentioning. It's also the investment that our plans actually in the US are just huge. You mentioned 600 billion. Actually, last year in the second quarter of 2025, 20 projects estimated with an investment of nearly 100 billion were cancelled or postponed due to problems related to grid or energy affordability. So storage is gonna play a key role here. We'll take maybe the question later on if there are any. And now we move to the last speakers from the Vinci Energy Consortia. So if you share your screen, please proceed.
I will share my screen.
Thank you for the invitation and for the opportunity to present our possibility for grid solution for data center at Vinci Energies. I would also like to welcome you, and my name is Stephan Timmel, and I work in business development at Vinci Energies under the Omexom brand. I have brought along two colleagues today, Johannes Sigulla from Omexom and Karstedt from Axians. They will guide you through the presentation. And so, Johannes, I'm happy to hand over to you.
Thank you, Stephan, and also thank you for having us at the webinar. So yes, my name is Johannes Sigulla. I'm coming from Berlin, but also I have my roots in Saxony. So that is the reason why there's always the connection also to Stephan, to my team member in Dresden. So I just want to show you some things about Vinci and also about Omexom and what we are doing. And after that, I will hand over to Christian, who is telling something more about Axians and their activities in the data center area. So Vinci is a company which is based in France, but has a real global activity. And we're in around 120 countries with a lot of experts, nearly 300,000 experts. And also we are in a business unit structure. Just to tell you what does mean business unit, we are really locally organized. That means every business unit has its own business for itself. So Berlin, for instance, Dresden, but also Leipzig. And also in Belgium, we have a lot of business units. So just to give you a short overview. And Vinci is a company which has several topics. At first, concessions. So in concessions, you can imagine that we are based in the area, for instance, of concessing airports, but also train stations. And then energy, where my colleagues and myself are belonging to, but also construction and immobilier area. So today we have Omexom and Axians in the meeting. So we will tell you a bit more about us and also the Vinci energy areas. So Omexom is a brand for the energy infrastructure. It does mean everything between low voltage, medium voltage, high voltage, and also the transportation lines is our responsibility. And on the other hand side, Axians is our brand for the ICT, the information and communication technology, just for a little overview. So to give you a short example, what we as Omexom are doing. So especially in Germany, we are around 5,500 experts. And as you can see, we have several business units which are based over whole Germany. And if I'm specifying, especially on Saxony, yes, we have several locations in Dresden, but also Leipzig. And we're broadly based in the German area. And Omexom does do at first, for instance, the power generation topic. It does mean we integrate renewable energies, if it's photovoltaic, wind power. In the last time, it is also more and more coming the battery energy storage systems topic with the integration. Integration does mean we build also substations, for instance, from 110 kV to 20 kV or 30 kV to connect the renewable energies. In the transmission network area, we are in the transportation area. It does mean we provide the lines for delivering the powers into the several areas. And in the distribution networks, it's more also the low voltage distribution area. And in the renewables energy, it does mean, yes, we are providing also installations for wind and photovoltaic installations, but also on the other hand side, so the more and more increasing market of the electrical vehicle. And focusing on the data center area, we as Omexom Energy projects are in several areas. So a project like a data center normally is beginning at the planning area. And that is the reason why we are already involved, especially in the electrical infrastructure topic. It does mean we're providing single line diagrams, but we are doing also network calculation to identify how many current is necessary in the data center, but also for instance, power control, we analyze at the beginning of the planning phase, and also the factory planning and cable routing. Cable routing does mean low voltage control cables, but also the medium voltage cable topic. And in the area of the project, it is the whole project itself. It does mean delivery, mounting, and also commissioning, especially medium voltage switch gears on raised floors. So if you have a data center, often it is connected also through a substation to the grid operator, and there we are also responsible for integrating the medium voltage solutions, but also onto the high voltage level. Therefore, we need also to integrate the transformers, but also the DC systems. DC systems does mean battery to have backup power in case of any interruptions also in the grid, and also protection control cabinets. And especially for sure in the data center, you can imagine there are a lot of cables which need to be routed in the area. So I want to give you a short example. So it's unfortunately not in Saxony, but it's in Berlin. And our customer, the NTT, which is an data center operator, installed already two large data centers in Berlin area. And we especially were available or responsible for the data center, which is in the south of Berlin, which has an all-over capacity of 19 megawatt, which we are installing, or which we installed, so the whole electrical infrastructure. And I just want to show you a short movie, and I hope it will work. Maybe not with the tone, but I will tell you something about it. So you here see the data center of NTT, which is in the south of Berlin, and it has two blocks which are completely the same infrastructure topic. Does mean you have low voltage, you have medium voltage, but you have also the whole installation for the data center itself. It does mean for their customers. As said, 19 megawatt of installed power, which you can here provide for the data center itself. And it has also generators. It does mean if there's any interruption in the grid, they will also operate furthermore. And for sure, it is highly secured. It does mean that is also the reason why I just can give you some information about the project in general, but not specifically on the infrastructure itself. I just can do it on the voice mode. So just a short view of the customer project. And it's a project where we installed the data center, but where we also had the chance to do the operation for the electric infrastructure. It does mean as Omexom energy projects, we are not only building it, in the most cases also the customers are asking us to operate the electrical infrastructure. We are not operating the computers, the AI infrastructure. We are in that case really operating the electrical infrastructure in that case. And that's so for now what we are doing as Omexom Energy project. It does mean planning, project execution, but also operation of the electrical infrastructure in the data center area. And now I would like to hand over to my colleague of Axians, Christian, who has some more insights also from the ICT area from Axians. Yeah. Sorry, I forgot some customers. Just, yeah. Thank you.
Okay. Thank you very much, Johannes, and thanks for the whole community to still be in the call. I know it's slowly getting towards lunch, so we are getting now to the content of the data center, which is our expertise of Axians, also part of Vinci Energies, working closely with our colleagues from Omexom and Actemium. This is our worldwide footprint. It looks very big, but I would like to emphasize the fact again that we are really local with our business unit setup. You can see here the 380 business units. So we have a lot of people really closely by your side and locally in your regions, both in Belgium and in Germany. Johannes, maybe you can move on to the next slide. Exactly, this should show a little bit the picture in Germany. Unfortunately, I don't have the picture for Belgium, but I can pass that on as well. So alone in Germany, we have 65 locations, and always the expertise and also the project management very close by your side. Next slide, please. So Axians is a classical IT system integrator and communication specialist. We have a bit of a speciality compared to other companies like NTT that we just saw in the video. We also have a very strong telecom infrastructure communication expertise. So we build and maintain large operator networks, fiber, 4G, 5G, which by the way also becomes more and more important in the data center environment. But then of course the cloud and data center infrastructure, which we are talking about here, the networking. We are one of the largest Cisco partners worldwide, the digital workspace, business applications and data analytics. Was very interesting to hear from the colleague half an hour ago to see the application of the data analytics of an industry into the data center. Thank you very much for that inspiration. So that's also something we do with our experts for industry and energy providers. And then last but not least, we have also very strong competence in the whole cybersecurity domain. Next, please. Johannes, next slide, please. Thank you very much. So I picked one example from Wallonia. It's maybe not the latest example we have, but it's one that very nicely shows how we are able, together with our colleagues from Omexom and from Actimium, to offer turnkey solution when it comes to the equipment, when it comes to the installation, the implementation, but also the operations of a data center. So we plug together the specific knowledge that is needed and that is demanded by our customers. Sometimes it can be including also industrial IT and OT integration. It can include the housing. It can also include fire protection. It can include specific needs for high performance computing. So in this specific case that we did for Zenaero in Wallonia, it's already 2-3 years ago, but it was around supercomputing with very special needs for the integration of technologies for the clusters, the storage clusters, and of course also at the same time the very high demand for the networking infrastructure within that computing center and data center. And this data center also a bit of a special one because it combines research computing facilities both for the university environment and for private environment. So this is a nice example that shows a lot of our expertise, how it is applied, because all what we have seen today in the end also needs to be built, implemented, operated, and maintained, and that's where we come to the play as the ICT brand of Vinci Energies. Maybe one last slide to summarize a little bit the work. So here you see all 4 brands of Vinci Energies. Omexom, we heard from Johannes, mainly from the electrical part and the connection to the grid. Then Actimium, the industrial integration. I think we also have an Actimium colleague in the call towards OT integration, what we also saw in the other presentation. Then Axians with the main ICT and AI knowledge. And we didn't see that in this presentation, but we also have colleagues in the building solutions environment for housing, technical building management, and for the fire protection. So for all of what we have seen, if it needs to be planned, built, implemented, and then in the end operated and maintained, you can reach out to us and we will plug together the expertise teams that are needed. Thank you very much. And I think we are almost in time for questions. Yeah, here. To reach out to us, here you have the mails and phone numbers. Thank you very much.
So thank you.
Thank you very much for both of you. Now I think there were many questions in the chat, but most of them are responded. I think Andre will take a few of them if they are still remaining.
Yeah, I see a question to Robert about feasibility of data center chillers. Robert, can you comment to this?
Yes. So it's a discussion that we had with a customer, but we are also, for the moment, focusing on the alarms management to identify then the contextualization for the optimization of these chillers.
Okay. Then I found a question going to Markus. What is a penetration and adaptation rate of supercapacitors in DC?
Yeah, so right now this is a topic that is, let's say, starting up. I mean, intrinsically, supercapacitors offer DC, but the integration into systems that can be connected with a DC grid is another story. So I would say this whole topic of more DC based infrastructure is something that's just starting up. So at the moment, supercapacitors, to answer it clearly, are not really that represented there, but I would expect this goes up or will increase in the future.
So I see another. Okay, thank you. I see another question going to LLC. The one collaborating DC enabling flex, it's in the context of comparison and so on. Can you answer this, please?
I think I answered below this one.
You already answered. Okay.
Yeah, I already answered in the chat.
Okay, you answered that in the chat. So I think that's all the question I could found now in the chat, which are not answered. Did anybody has another question? Then please highlight it in the chat.
Okay, maybe since we are heading to the end of our session, we're getting there. I have a small question, maybe for the Walloon actors. I heard from Nicolas' presentation that there is no room actually for flexibility. I wonder, like here in Wallonia, for instance, we have a real problem with grids, and we got a question actually from Canopea regarding the Sigulla project, where they actually ask about the potential flexibility that could be provided, because according to Google, apparently there are some priorities in the use, for instance, reducing the quality of YouTube videos at some point. Is that something that could be also considered in Wallonia? And also, given that in 2027, according to Elia's grid capacity hosting capacity map, there will be only one spot if there's no flexibility at all. How do you deal with this? Because it's a situation, if you need to increase your activities, then how will you deal with that issue to get a spot, knowing that there are other uses that are in the queue? Thank you.
Yeah. For LCL, the point is we don't manage IT, we manage facilities. That means we don't have actions, possible actions on the IT load. So that means if the customer consumes 1 megawatt, we don't have the choice to say, okay, guys, we have to move in another country or in another location of the Belgium where the flexibility is not present. That's one thing. The second thing is if we receive flexibility, obviously we decide to use our generator to have an idea how many times we could be cut off and how many times we have to produce our own energy. Maybe we have battery, like in the presentation we have, is something we are obviously looking for. The idea, if we can discuss with the area or ORES or Fluxys anyway, to discuss, to say it's possible to receive a grid without any flexibility, we prefer, obviously. And if they can put the flexibility for other companies, we can also work together. The goal for LCL is also to look into not via silo. Today, when we ask some things to area, they say, okay, what you going to install on site? If we say, okay, maybe we can use also a battery with a third party, a heat network, and to have visibility more broader, that just instead a box called data center and a consumer. That's also, this is very a big challenge, I think, for us.
Okay, yeah, that was pretty clear. Thank you very much. I guess there is no more questions. So thank you everyone for joining us. These are the contacts, and also we share the slides if the speakers, all the speakers agree to that. We have an interesting mission in next November. You can find all the program there. It will be in Vienna. on a grid and energy topics. It's quite interesting, and we are having this nice pavilion with our Flemish counterpart cluster in Flanders, and there are also interesting webinars that are coming on. The next one is about electric mobility. Please join us, and if you go to our website on the agenda, you'll find all this information to subscribe. Thank you very much. As you have noticed, this webinar has been recorded. It's also for the feedback, and it was great having all of you. This actually shows the interest that is on the topic. Thank you, and see you very soon. Bye bye.
Thanks again.
Thank
bye.
you very much. Bye.
Thank you. Bye.
Thank you. Bye bye. Thanks, Rémi. Merci.